detail about the second line of difference and what that means in terms of the quadratic sequence. All right? But we're not. We're going to do it in a slightly different way. So we're going to start looking at what is the general form of a quadratic function or formula, or what does it look like? So if I said un equals, what would you expect a quadratic to look like?
Oh, an squared plus bn plus c.
Okay. An squared plus bn plus c. All right? A quadratic will be some along those lines. You recognise it, yeah? Ax squared plus bx plus c we've done before?
Yep.
All right, so we're going to use that. And what we're going to do is we're going to carry on working out this general form of a quadratic sequence. And we're going to work out an algebraic way of working out what a, b, and c are if we're given a sequence. So we're going to start by looking at what would u1 be, okay, in algebraic terms if I don't know what a, b, and c are yet. So in terms of a, b, and c, what would u1 be?
A plus b plus c.
Okay, so u1 would be a plus b plus c. Is everyone happy with that?
Yep.
You know why? Could you explain why to me?
Well, because the n's are just 1.
Yeah.
So it's just going to be a squared plus b.
Not a squared.
Sorry, and then since n is 1, it's going to be 1 squared, which is just 1, and so it's going to be a times 1, so it's a plus b plus c.
Yeah. You got that, Ethan, as well? Yeah? So if n, for u1, n is going to be 1. So that would be a times 1 squared is a times 1, which is a. This would be b times 1, which is b. And there's no n in c, so you're going to have the c. So it's just going to be a plus b plus c. Whatever it is, that's what it will be. Right? Whatever a, b, and c are, the first term of a quadratic will be a plus b plus c. Right? What would the second term in the sequence be? Someone else. Zoe.
A. 4a.
4a, good. 4a plus
2b plus c.
Good. What would u3 be, Ashley?
12a. Wait, no. 9a.
9a
Plus
3b
plus c.
plus c. Ethan, u4 would be?
Oh, this is just trinomial. No, it's not. It's
Ethan, what would u4 be? So chucking 4 into there, it'd be?
4a.
No, because it's 4 squared is
16.
16a's plus
4b's
plus c. Okay. And I'm just going to do the fifth term. Greg, it'll be?
25a plus 5b plus c.
Okay, so my sequence, okay, whatever the numbers are, they should relate to these A, B's and C's with whatever A, B and C would be, okay? Maybe it'll make more sense when we've gone through the process. What do we do when we try and find a general rule for a sequence? We first look at the
Pattern.
which is we look at the difference. So let's find the first line of difference between these two. So how do you find a difference between two terms? You subtract them. So what is 4a plus 2b plus c subtract a plus b plus c?
3a plus b.
3a plus b. What do you notice has disappeared?
The c.
The c. The next one is going to be
5a.
plus b. The next one is,
7a.
7a plus b.
and the next one is?
9a.
Okay. But we still have a changing number here because I've got a's and b's and I've got different numbers of a's. So it's still not going to be a common difference. So now we have to go to the
Third line. of
the
difference.
third line of difference. Or,
is
well,
that
no,
the second?
this is the first
Okay,
line of
yes, it's the
difference.
second.
The second line of difference, which is going to be
2A.
2a. It's going to be
2A.
2a. It's going to be... So that leads us to a conclusion that the second line of difference will always be double whatever the a is going to be.
Oh.
Yeah?
Okay.
Makes sense?
Yeah.
So if I can work out what the second line of difference is, that will tell me what the a is. It won't tell me what the b and c is. It will tell me what the a is. Now, this diagram was easy enough to come up with, yeah?
Yeah.
Okay? So I'm not asking you to memorise it, but I am suggesting that you might want to remember how to get to it. It's not hard, is it? Right, now what we need to do is use it somehow. All right? So I am going to write down a very basic quadratic sequence for you, and you can probably tell me the rule for it before we do any of this. So if I write down a quadratic sequence, a really simple one, not the most simplest it could be, but a simple one, I'm going to write down 2, then 8, then
16, 14,
2, 8,
8 times 3.
18,
Oh, yes. I see.
32.
okay.
What's next?
64.
No.
50.
No, 50. I'm still thinking this is just a linear.
What's the rule? UN, make sure you've watched the video. UN equals,
Something times 2.
it's
Yeah.
2 lots of n squared, because U1, U2, U3, U4, U5. So 1 squared is 1, double it. 2 squared is 4, double it. 3 squared is 9, double it. So we know it's 2n squared, that's all it's going to be. But what we want to do now is let's see whether we could prove that it's 2n squared or find it another way, because obviously then when it gets more complicated we can use the method, right? So what's our first step? Our first step is to work out what the second line of difference is. So what's the first line of difference? 6, 10,
10.
40. Yeah? What's the second line of difference? 4, 4. Okay. So, this is how I can use that other diagram using this. Do you want me to hold a sec while you write? Yeah. So, referring back to your previous diagram, can you tell me what the algebra for this term was?
Oh, the algebra?
It's 2a. Do you remember I said that?
Yeah.
What was the algebraic term for this first one in the first line?
3A plus B.
3a plus b. Come on, computer. All right? Got that? So what can I do now? I can solve that. If 2a is 4, I know that a must equal
2.
2. I know that if 3a plus b equals 6, I can now substitute that in and say that 6 plus b has to equal 6, which means that, so 6 plus b equals 6 means b must be
0.
0. Okay. What did I know about the first term too? That was a plus b plus c equals 2. So that means if a is 2 and b is 0, c must equal
0.
0. So I've shown that in my general form, if un equals an squared plus bn plus c, I know that a is 2, b is 0, c is 0. So I've confirmed that it's 2n squared. Yeah?
Yeah.
So that is very different from their whole, right, find out how many n squareds, then look at the difference between that sequence and what's left. That's another way forward, okay? Can you pick another one out of the book? Sorry, I need to take the book. Let's see whether you can do it for another one. So have a look at another sequence being 412 36. No, that was too easy. Let's do the other one. 2, 4, 7, 11, 16. Oh no, sorry, I don't want to. So, page 283, question 2. Have a go at that. There's some negatives, but that shouldn't matter because you use this same method, come up with a formula for that quadratic formula. So I've run through this. I've used the method that hopefully you're using. So I've found the differences. You know, you don't actually need all of these, do you? If you know it's a quadratic, you actually only need to find the first triangle. And I've solved my algebra over here. The reason why I wanted you to do this one is, what was your initial reaction when you saw these numbers?
That can't be a pattern.
Can't be a pattern, right?
Yeah.
Because it looks like, oh, it's low, then it goes up. But what do you know about a quadratic function? What does it look like as a graph?
This?
Not quite. A quadratic looks like either that or up the other way, doesn't it?
Oh, that's why it's mirrored. In the...
That's why it's negative 18, negative 18.
Who did that?
You did that, which is not. It will go on forever down like that, won't it? It won't balance, right?
So we continue after this?
Yeah, so, but can you see how that threw you to start with, but if you go through the process, it actually makes sense with the shape of the curve as well, okay? Yeah, so if you're happy, there's two things I want you to do now, which is you can go on to page 284 for practice 6, but what I need you to do is actually keep going until the end of this topic, 8.1, because you'll start looking at the mixed practice has things to do with patterns in it, like the honeycomb. So it's where you actually have to come up with a sequence from a pattern of physical shapes or something like that. So you're counting shapes or you're counting vertices, and that is normally what will be in an e-assessment. One of the final questions will be how many hexagons are there, or that kind of thing. How many points of intersection on a circle. All right, so you can go on to practice 6, but your job now, today and for the rest of today, which is 5 minutes, and tomorrow's lesson, so you know what you're going to do as soon as you turn up in class, is get these two things done. All right, then the next thing we want to do is literally a one lesson, get on with it, have a read, finish, and it'll be done, and we'll have got halfway through this unit.